AP Stats, this is Mr. Kim. So in this video, you will see how to do the first 20 questions of the multiple choice section for the Chapter 8 review. As you know, the test will be taking place tomorrow. This will be part 1, and I will upload part 2 shortly, along with questions 21 through the last question of 33 of the multiple choice. As well as up until question 36, which is the open-ended as well. So without further ado, let's get started. Number 1, each figure below displays the sampling distribution, the true value of the population parameter, which is the sampling distribution of statistic that is an unbiased estimator. If we have an unbiased estimator, what that basically means for us is that the true value should happen in the center of the distribution. So the only one that actually has that is going to be statistics 3. Now notice that the true value for statistics 1 and 2 is actually a bit off, which means either the sample was not randomized, which created this bias in the first place. So the only answer here will be C, and you'll be able to move on from there. Number 2, a planning board in Elm County is interested in estimating the proportion of its residents that are in favor of offering incentives to high-tech industries. So we have a 95% confidence interval. We have the interval between 0.49 to 0.59 here, which of the following statement is going to be correct. So at the 95% confidence interval, the estimate is within the true proportion of the county residents in favor of offering incentives. At 95% confidence interval, the majority of area residents are in favor of offering incentives to high-tech industries to build in plants in the country. So between A and B, obviously what you want to do is you think that A would be the better choice, because B is just kind of pretty much saying the same thing as A, but A offers the actual numbers with the confidence of the interval in which it captures the true value of the percentage of the people who's actually in favor of building high-tech industries, blah blah blah. Since we're asked to find out the statement is correct, among C, D, and E, in repeated sampling, 95% of sample proportion will fall in the interval. Yes, but however, the best statement, because we're talking about which of the following statement is correct, it's actually going to be A in this case, because when we say the repeated sampling 95% of sample proportion, this actually represents what 95% confidence interval means. In a repeated sampling, the true proportion of a county residents in the favor of offering incentives will fall. Well, D is absolutely not true. It only happens about 95%, or you're at 95% confidence level in which you can actually claim that. And the last one is, in a repeated sampling, 95% of the time, the true proportion of the residents in favor will be equal to. We never want to say it's equal to. It's going to be within those two boundaries, so it's going to be any values between those two. So E is obviously not the one to go. If you're given a choice between A and C, A is obviously the one that actually is. It's longer, it sounds smarter, and this is the correct statement that you want to say for the context provided. Number 3, which statistic is most likely to result in an estimate that is close to the true value of the population characteristic? Okay, so honestly, you can see that how statistics 1 and 2 is kind of biased. The true mean is not actually at the center, which is the true value. Now, between the statistics 3 and 4, what you want to actually pick is the one with the narrower width, because it says which statistic is most likely to result in an estimate that is close to the value. Well, because our width is small, that means our margin of error will be smaller. So therefore, I believe statistics 3 should be the correct answer for number 3. In a random sample of 300 elderly men, 65% were married. So P1 hat would be 0.65, and this is P2 hat is 0.48. 99% confidence interval estimate for the difference between the proportion of elderly men. So now, guys, at 99% confidence interval, it means that the critical value, in which we call, actually, you can think of it as the Z-score, at the 99% confidence interval means you have to use an inverse norm. Now, what do we put the inverse norm as? Well, think of it as 99% in the middle. This and this, they constitute of 1% in total. So this actually has to be about 0.5%, or you can leave it in decimal as 0.005. So what you would do is you would take out your calculator here. This is something that I do not want you to do. Like, oh, I see 99%, so this is what we're going to do. That is a grave mistake. You're going to go to second varies and you're going to go to inverse norm. Area is 0.005 for 99% confidence interval rate. You'll press paste. And what you're going to do is you're just going to get 2.575. It's a good idea to memorize these numbers before the test so that you don't get confused, or you don't even have to bother doing this of figuring this out on your own. 99% confidence simply means that. And now what you're going to do is you're going to actually use the formula that states P1 hat 1 minus P1 hat over N plus P2 hat minus 1 minus P2 hat over N. Maybe I should label the subscripts for N as well with N1, N2. So this, if you actually type it in, we get 2.575 parentheses square root of this 0.65 for men, so 0.35 for the percentage of the other half over 300 plus 400 elderly women, 0.48, 0.52. So I'm going to put all of that into the calculator here. And we are going to find out our margin of error. Square root of 0.65 times 0.35 divided by 400. I'm going to put in one parentheses plus 0.48 times 0.52 divided by 400. And you're going to get 0.034. But you multiply that by 2.575, the critical value. It seems to me that our margin of error is anywhere between 0.088 here. Okay, so that will be our critical value. Sorry, not critical value, but the margin of error here. So we have 65% that were married. I'm going to just put it like this. And then this is 48%. So we're talking about the difference of the proportion. So we're going to of men and women. So we do 65 minus 48, which should give you 17%. So we can eliminate C, D, and E. Between the two answer choices that I have, it obviously seems like B is the closer one. But quite in all honesty, I feel like I might have made a mistake in terms of maybe putting in the wrong numbers into the calculator. Oh, right. So this was the reason why. So I should have just put 300 for this. Sorry. So this one, I'm going to have to change this to 35. And then this is 300. And now that's more like it, times 2.575. There we go. So I just made a silly mistake on the calculator. Sorry about that. But basically the margin of error should be 0.096. And the rest is history. All right, number 5, given a choice of unbiased statistics, the best statistics would be the one with sampling distribution that. Okay, so here we want to eliminate C, has the largest standard error. That's completely the opposite of what we're trying to do. Is most nearly symmetric, is most nearly approximated by a normal curve. They pretty much mean the same thing, but we're not talking about the shape here. Okay, the shape is not actually the best idea. T distribution we haven't talked about. We want to pick the one that has the smallest variance, which means our sample size is the largest, which means our standard error is decreased by a lot. It's minimized as much as possible. So number 5 is B. Number 6, in order for us to use this, what combination of N and P? Remember, NP has to be greater than or equal to 10. So let's take a look at these two. If you multiply them, you get 8, you get 8 again. So A and B are not the correct choice. This is 5, not working. This is 4, so D is the correct answer. This should give you about, approximately, what, 70-ish or so? Just to check, 150 times 0.45. That'll be 60 and a 67.5, I believe, maybe. Yeah, there we go. So 67.5, obviously that works, bigger than 10. So you move on. All right, so 90% confidence interval, blah, blah, blah. Okay, so we're looking at the sample sizes for number 7, and it seems like one of the sample sizes, because it was plugged in as 9,000, our confidence interval, which is obviously the critical score, times p hat 1 minus p hat over n. Imagine for a second I just have 9,000 here versus the same exact formula, but p hat 1 minus p hat, and now it's going to be 1,000. Now, how is this going to fare out is the question. Now, because you're dividing this by 9,000, which is 9 times greater in the denominator, I mean, you guys can just obviously make up numbers for this. Z-score, you can just make it as 1.96, 2.57 from before. P hat, call it 0.5 or whatever, and you can compare the numbers of the two and see the difference. So why don't I just show that to you real quick? So let's say I make up a random number for Z-score. It's at 95% confidence interval, and then square root of 0.5 times 0.5 divided by 9,000. Now take a look at that interval or your margin of error versus the same exact thing, but then I'm going to change this from 9,000 to a 1,000. So now when you take a look at these two numbers, what you should notice is that this one is actually higher than this by, well, how much? That's the question, right? So let's take these two numbers and divide. You basically got about 3 times as bigger amount of the width here. So remember, as the sample size increase, your variability decrease. So this one should have the smaller, this one should have the larger one. So how does assuming that what will be the relation between the width of the original interval and the width of the second one, 90% confidence that is created based on only that? Well, this one's is obviously going to be a lot smaller. The second in confidence interval will be 3 times as wide. That should be the correct answer. So they're all talking about how the second confidence interval would be. If they said the first confidence interval would be 1/3 times, then obviously D will be the correct choice. But since that's not the case here, the answer here should be B. All right, number 8. Suppose that a random sample of 100 high school classrooms. And number 8 is one of those really iffy ones. Now, all I'm going to say is, which of the following is a correct interpretation of the 95% confidence interval, it says. So they're asking you for what is the 95%? Like what does this mean? Okay. Now I know a lot of you guys might be thinking, okay, B is not the correct choice. Maybe not E, because we really don't say none of the above unless we actually read them through. There's a 95% chance. We usually start with a template that says we are 95% confident that the true proportion of high school student classrooms in California have internet access between those to that. Now, if they said that, what is the correct interpretation of the confidence interval? That's when you say D. Now, I know that may sound weird, but when they say, what does this 95% entail? What does this mean? Like, how does the 95%, like, what would that have an effect do? Yes, it means that we are 95% confident that this interval would capture it, but that's really talking about the interval itself, not the 95%. So the correct answer here is A. The method used to construct the interval would use an interval that includes a value proportion about 95% of the time in repeated sampling. So quick rule of thumb, if they ask you the percentage confidence interval, what does the 95% mean? What does that 95% confidence interval mean? This is the description you want to give. Vast majority of the cases, you're not going to get that. They're just simply going to ask you to interpret the confidence interval that you found. So they will just ask you interpretation of the confidence interval. They're not going to ask you for the 95%. They're just going to ask you to interpret the interval itself. That's when you would use the go-to the template that we're used to. We are 95% confident that blah, 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 blah. That is what you would do. Okay, so that is number 8. I'm sure I'm going to have some questions regarding that, probably tomorrow or Tuesday. So I'll go over that with you. Number 9, an SRS of size 100 is taken from a population proportion of 0.8, independent sample size is 400. Okay, so this is combining the two. Sampling distribution for the difference in sample proportion has what standard error? Okay, so standard error, P1 hat, 1 minus P1 hat over N1 plus P2 hat, 1 minus P2 hat over N2. So let's plug just everything in. 0.8, 0.2 over 100 plus 400 on the bottom. This would be 0.5, 0.5, and square root the whole thing. So you would just go to your calculator. So 0.8 times 0.2 divided by 100 plus, maybe I should just do this separately. 0.5 times 0.5 divided by 400. So I'm going to add that with this and then square root the whole thing. And then I basically get the answer, which is C, 0.047 for 9, and that should be correct. Number 10, which of the following must be true of a sample in order for it to be appropriate to use a Z confidence interval? Well, there are a couple of conditions you need to keep in mind. I obviously see B as one of those. The sample is a random sample from the population of interest. The randomness has to be there. The population distribution is normal. That is not a necessity. All of the above are required. Nope, it's just E for this one, for number 10. Which of the following would tend to decrease the width? If I want to decrease the confidence interval, there are two ways. Number one, we increase the sample size. Number two, we actually have a lower confidence percentage, the 90%, 99%, 95%. If you decrease the confidence percentage, the confidence level, you would also decrease the confidence interval width. So let's increase the sample size using a lower confidence interval. So 11 should also be E. Researcher has conducted a survey, 50 registered voters to create, assuming that this sample portion does not change, which of the following best describes the anticipated effect on the width of the confidence interval if a researcher were to survey a random sample of 200 rather than 50. Remember, it's the same exact question as we have done here before, number 7. When we go from 9,000 to 1,000, we basically increase the sample size by 3 times as much from before. Now, what happened is here, we went from 50 to 200. The width of the new interval with the 200 random sample size should be actually giving you a smaller variability, which would also give you smaller confidence interval. Okay, so because by increasing the sample size, remember, we talked about this, it's going to decrease the width of the confidence interval. So the width of the new confidence interval will be about 1/4, 1/2, the same, the twice, the 4 times. So we're eliminating CDE because they're talking about either being the same or higher. No, we want to talk about how this confidence interval is lower. It's much, much lower. So how do we figure that out? Well, we went from 50 to 20, which means it's actually times 4. We're multiplied by 4 in sample size. In effect, if you plug all the numbers into the formula, remember p hat 1 minus p hat over n, that's whole square rooted. Imagine the 4 is now on top of it. The square root of 4 in the denominator will cause the denominator to have a 2, which means the width of the new interval will be about 1/2 of the original interval there. A large sample of 98% confidence interval. Wow, that's new. I always told you 90, 95, or 99. 98% is new, but whatever. Cancel the indent. Okay, so we have that. What is the point estimate for the proportion? Point estimate means to solve for the z-score. That's 98%, which means that's 1% and that's 1% because they all have to add up to 100%. So how do I figure that? Second vars, inverse norm, 0.01, because that's 1%. Move everything down. Remember, your mean and the standard deviation by default should be at 0 and 1, negative 2.3. That are canceled on the intended arrival day from which this interval was conducted. Okay, so it seems like we want to find out the point estimate, which we did. And for 13, so let me first write down the z-score here. Inverse norm, so it's 2.326. The proportion of the hotel reservations that are canceled on the intended arrival day. Oh, so I believe that when you take a look at these two numbers here. So 0.048 and 0.112, when you add them up, you actually get 0.160. So the middle number that is actually part of this interval, which would be 0.160 divided by 2, because you add them up and divide by 2 to find the middle number. So that'll be 0.08. So when you actually construct your confidence interval, it'll be 0.08 plus and minus your margin of error here. This will be your point estimate, in which it kind of tells you like where you're starting from, your middle point, your true mean value, and you either move left or right by the margin of error, basically. All right, number 14, each individual in the random sample of 50 internet users was asked how many minutes. So the data was then used to construct 99%. The confidence interval was that. So look at what the question is asking. Which of the following is a correct interpretation of the confidence interval? They're not asking you what the 99% confidence interval means. They're asking you to interpret that interval, 80 to 200. What does it mean? So we are going to eliminate A. We're not going to start a sentence like that. We're not going to start a sentence like D or E. We are always going to start with the we are statement whenever they're asking us to interpret the confidence interval and confidence interval alone. We are 99% confident that for all internet users, the mean number of minutes spent online in a typical day is between 80 to 200. Better choose C rather than B. B is just not good enough to become the correct answer here compared to C. So 14 here is C. 15, we have the percentage. 95% confidence interval. So what is the standard error of the difference? It says, so let's do 16 out of 85. That is a 69 out of 85 over 85. I think that's the sample size. Plus 19 out of 67. That is 48 out of 67 over 67. And then we're going to just type that in our calculator and let's see what happens. So first of all, 16 over 85, because I believe that's the first thing we typed in. And then 1 minus that answer times this answer divided by 85. So that gives me about 0.0017976 for this one fraction. What is that? 19 out of 40 over 67. 1 minus that answer, and then times 0.28 divided by 67. So I get 0.003032. So that's that one. Now, when you add that up with this answer that we have from before, square root the whole deal, you get 0.0694. So that should be B for number 15. Yes, so that should be your standard error, not your margin of error. Standard error is the part that actually comes after your z-score. This part, SE, let's call it that. And let's move on. Which of the following is certain to reduce the width? Remember, reducing the width means you're increasing the sample size or you're lowering your confidence percentage level. So lower confidence level, larger sample size, 16 should be B. The critical value for 99% confidence interval for P is equal to. This means the critical value that you want to be using for 99% confidence interval, there's only one thing you can possibly do, which is just to find out what the z-score is going to be. If I could just pull the calculator up here. All right. So if we're talking about the 99% confidence interval, remember your P is 0.005. So let's do second inverse, second varies, 0.005. Then we're going to scroll all the way down. And then we get 0.8. Oh, there's a cosine for some reason. Okay. So we get 2.575, which then that should be the answer B. So that is your critical value. Now, they don't tell you what the mean is, like, plus and minus, like what P hat is at this moment. So since they don't tell me, I can assume that 2.575 multiplied by this, obviously we call it the standard error. So P is equal to 2.575. That will be the 99% confidence interval. That's the number you would like to use. So when you see a question like this asking for just the straight up only information is giving you is the 99% confidence interval, what you would do is you would just use inverse norm and get that z-score value. Okay. All right. Next question, number 18. Based on the survey of the N is 900 in the United States, 60%. So P hat is 0.6, increasing the minimum hourly wage. If the reported percent has a margin of error of 2.7, okay. So here's what we're going to do. We want to find out the closest level of confidence, which means they're really asking you to solve for the z-score and match it with whichever gives you the closest z-score as possible. Now, the formula is P hat times 1 minus P hat over N square root the whole thing. And this has to be 2.7 as your margin of error. That's your standard error. This part put along with z makes it a margin of error. So let's plug everything in first. 0.6 times 0.4 over 900, and let's square root that whole thing to find out what I need to multiply to z. 0.6 times 0.4 divided by 900, square rooting the whole thing, you get that. Okay, so I get 0.0163. So z score times 0.0163 has to equal 2.7. Let's do some algebra. Obviously, take 2.7 and divide by that number because, you know, you got to get rid of it on both sides like this. So what I get is, oh, I'm sorry, this is 2.7 percentage points, not literally 2.7. That's totally my fault. So 0.027 divided by this number. And what do you know? You get a z-score of 1.65. And I believe we've seen this before, but let's do it again. 1.65 is somewhere between, you know, having 1 or 2 standard deviations away. So let's try the 95% because that's one of the most commonly used ones. Remember that when you do second variance for 95%, you got to make sure that this is 0.025. Well, why is it 0.025? Well, that's because the 95% is in the middle, 5% together, half of that is 2.5% on either end of left hand or right hand side. So I have a z-score of 1.65, and this is 1.95, which means C, D, and E, they're way too big in order for this to be the answer. Let's try 90%. If it's 90%, how much percentage points would I have to use for inverse norm? Well, if you think about it, 90% is in the middle. That means 10% together on left and the right hand side. Only 5%, half of that remains. So let's change it to 0.05 and see what you get. Now that is more like it. You see how the inverse norm gave me about a score of 1.644-ish, and z-score that we want to find out is 1.65. It looks like we have a winner. It's the closest one we have. Number 9, assuming that the data came from random sample, what other conditions must be met? Okay, so first of all, A is a central limit theorem. We don't really need to have that. The population of interest is greater than the sample size. Now that has to be true. That's the 10% rule, which states that the population has to be greater than at least 10%. Actually, C is the better answer because C literally says what I just told you in a much more specific sense. So B is out of there because C is a better choice. The probability of success times the sample size. So that is n times p has to be greater than or equal to 10. D sounds about right. That's the rule of large counts. So it looks like E is the right answer for me, guys. So I'm going to erase these two and just say E. All right, last question, and then this will be the final question for the part 1 video. What size would a sample need in order for it to be within 3 percentage points on a 95% confidence interval? Remember, guys, a 95% confidence interval from before that we found was 1.95, okay? Or 1.95996. We're going to be using that number, and it says about success rate is 0.36, failure is 64. N is the one we want to find out. You're going to square root that. That's 1.95 times this whole thing is within 0.03, which means it's got to be not greater. It's got to be less than or equal to 0.03. Quite honestly, though, you can kind of set them equal to each other and solve it that way. It still wouldn't make a big difference. First thing, algebraically, you want to get 1.95 to the other side by just dividing that away like this. So we're going to take the 0.03 divided by 1.95. Actually, it would be better if I just use this whole number, right? Multiply that by -1, just so that I can just look at the positive numbers. So 0.015306 seems to be equal to this square root shenanigan. So I'm going to square this so I can get rid of the square root. And then I get 2.342 e to the -4, which means I moved decimal point left 4 times. That is 0.36 times 0.64 over n. So I'm going to do this first. It gives me 0.2304. If I were to take that and divide by that answer, I exactly get what the size n should be. Oh, I'm sorry. Maybe I made a mistake here. So if it's within 3 percentage points, it means 0.03. We divided that by 1.95. Let's check the answer here. Okay, good. 3% of the confidence interval. Okay, so we have that. Then we square the whole thing, and then we take the 0.03. Okay, so we take that 0.2. Oh, no wonder I made a mistake. So it's basically this number divided by this number, but not this number. You know what? I'm just going to start from the top because it's not working out. Okay, so what I wanted to do was 0.03 divided by, what's this number? And then times -1. And then you're going to square that number. So you get 2.34 e to -4. So 0.36 times 0.64, which is that, divided by this number. And you get n is equal to 983.41. Guys, if you're confused as to what I just did, think about what happens. Like, you got to get rid of the n by multiplying by n on both sides like this. Then you get basically this times n is equal to that. So I just took the 0.36 times 0.64 and divided it away by the 2.342 number onto the other side. And I got n is equal to 983.41. Here is the choice. Which one should I go for? You're choosing A. If you go 983, you're cutting it short. Remember, 983, yes, that's part of the answer, but it's 983.41. You need to put this as your n in order for you to get exactly 0.03. Anything less would mean, remember, smaller sample size means bigger the variance, bigger your standard, your margin of error, which means you can't get it within 0.03. Rather, it's going to be above 0.03. So rather increase your sample size by one insignificant one more sample size, in which now your margin of error will be within 0.03 points. Okay, so I made this video super late in the night, so maybe my voice is a little bit different from usual, but I hope this video helped in terms of understanding at least half of this packet. Hope to see you guys tomorrow and have a good day.